Hey students, welcome. In this explainer, we are going to totally crack the code on pH value questions. My goal is to help you feel super confident so you can absolutely ace your SPM chemistry paper.
Okay, before we jump in, just a quick tip. The best way to get good at this stuff is through active practice. You can find a ton more questions over at MCQ SPM.com or just download the MCQ SPM app. Seriously, it's a great way to supercharge your revision.
So let's get real. Why do so many of us find these pH questions so tricky? It's usually that mix of remembering the concepts and the formulas that can feel a bit overwhelming. But trust me, by the end of this session, you're going to see how to turn these tough questions into easy, guaranteed marks. All right, let's start from the very beginning and build a rock-solid foundation. We've got to understand what pH times really is, because once you nail this core idea, everything else just kind of clicks into place.
Okay, don't let the word logarithmic scare you. In simple terms, pH is just a scale, usually from 0 to 14, that tells us how acidic or how alkaline a solution is. And what's it all based on? It's all about the concentration of those teeny tiny but super important hydrogen ions.
I want you to think of the pH scale as a kind of power meter. See here? Anything below 7, that's your acidic zone, and the lower the number, the more powerful the acid. Anything above 7 is alkaline, and right there, that perfect 7 smack in the middle, that's neutral. Think pure water. Now, here's a really important idea that trips a lot of students up. Look at this. You can have two acids, like hydrochloric acid and ethanoic acid, at the exact same concentration, but they have totally different pH values. So what gives? Well, it all comes down to something called the degree of dissociation. Let me give you an analogy. Think of a strong acid like a plastic bag full of marbles that just rips wide open. Boom, all the hydrogen ions spill out at once. That gives you a really high ion concentration and a very low pH. But a weak acid, that's more like a bag with just a tiny little pinhole. The ions just trickle out slowly. So at any given moment, there are fewer free ions, which means, you guessed it, a higher pH. All right, time to move on to the math. Now, don't get nervous when you see the formulas. I promise, they're way more straightforward than they look, especially once you see how they work. So this is it, the big one for acids. The pH is simply the negative log of the hydrogen ion concentration. All you have to do is pop that concentration value into your calculator, hit the negative log button, and bam, that's your pH. Now, for alkalis, listen up because there's a really important extra step. You can't just calculate their pH directly. First, as you can see in step 1, you have to calculate something called the pOH, using the hydroxide ion concentration. Then, for step 2, it's easy. You just take that pOH value and subtract it from 14 to get the final pH. Okay, exam alert. This is probably the most common mistake students make. They do the first calculation, they get a pOH value of, say, 1, and they just write that down as the answer. But wait a minute, a pH of 1 is super acidic, and we're talking about an alkali. You have to remember that second step. Do not fall into this trap. Okay, that's enough theory for now. Let's put this knowledge into practice and see how these exact concepts pop up in actual SPM exam questions. This is where it gets fun.
Here we go, a perfect example from a past paper. Notice there are no calculations needed here at all. This is a pure test of your understanding. We've got 4 alkaline solutions, they all have the same concentration, and we just need to find the one with the highest degree of dissociation.
So let's walk through the thought process. What are the keywords here? Alkaline solution and highest degree of dissociation. Now let's connect those ideas. We know that for an alkali, a higher pH means more hydroxide ions are floating around. And what does that mean? It means a higher degree of dissociation. So the logic is actually really simple. Just find the solution with the highest pH. And if we follow that logic, solution N with its pH of 13.0 is clearly the highest. So that's our answer. See? Super simple. Those are easy marks right there. All right, let's switch gears to a calculation question. Now this one is a classic. It's got a little hidden step that is designed to catch students who aren't paying close attention. Okay, the trap is laid right there in step 1. Look closely at the chemical formula, BaOH2. See that little subscript 2 outside the brackets? That is the most important part of this question. It tells you that every single molecule of barium hydroxide releases 2 hydroxide ions. So many students forget this. You have to double the concentration they give you, so it's not 0.05, it's 0.1. Once you do that, the rest is easy.
pOH is 1 and the final pH is 13.
So just by remembering to look for that tricky subscript and account for both hydroxide ions, we correctly get to our final answer of pH 13. Nicely done.
Let's wrap things up with a final cheat sheet. I seriously recommend you pause and take a screenshot of this next slide. It's got everything we've talked about, and it's perfect for that last-minute revision before the exam.
And here it is. This is your key to success. We've got the basic definitions, the link between strength and dissociation, how concentration impacts pH, both of your key formulas, and of course, that super important exam tip about watching out for things like BOH2. If you can understand and remember everything on this one slide, you are going to be in fantastic shape.
So there you have it. You've got a really solid foundation on pH now. The next logical step is to see how all this applies in neutralization reactions in a process called titration. Keep practicing, keep working through those past papers, and you'll be ready for whatever the exam throws at you. You've got this.